Hello everyone. This is the first of a series of lectures covering software engineering. For this first topic, we'll be looking at the introduction of software engineering. The scope of this lecture is as follows. First, we are going to look at what is software engineering. Next, we're going to examine the software development lifecycle model, or SDLC for short. Next, we are going to examine the unified process as a development methodology. And finally, we will learn what are the unified process disciplines. At the end of this session, you will be able to define software engineering, describe the main activities in software engineering, explain SDLC, its phases, and its objectives, explain what unified process is and its important characteristics, explain UP disciplines, and finally, list the 9 UP disciplines, the objectives, and activity list. So, what is software engineering? The phrase software engineering consists of two words, software and engineering. Simply put, it is the development of software system following conventional engineering philosophy. To be more precise, software engineering is a discipline whose goal is the production of quality software that is developed on time and within budget that satisfies the user's needs. As with any engineering fields, it encompasses the following: processes, management techniques, and technical methods in order to achieve the software engineering goals. As with any engineering discipline, this covers numerous activities. These activities can be classified under three main categories. And these are management techniques, software development processes, and technical methods. The activities classified under management techniques are to monitor progress as well as to control changes. And the activities classified under software development processes mainly focused on project planning and requirement development. And technical methods focus on requirement gathering techniques, object-oriented analysis and design, testing, and coding. And in this series of lectures, under object-oriented analysis and design, we'll be focusing on UML modeling. Software Development Lifecycle, SDLC. As in any life cycle, to develop a software system or application, the process would have to undergo certain stages from inception to the final system or application. So, in a software development lifecycle, it involves the process of building, deploying, using, and maintaining a system. There are 5 main groups of activities known as phases in a software development lifecycle. These phases are planning, analysis, design, implementation, and support. This lifecycle is commonly known as the waterfall model. Waterfall because the phases start from planning, analysis, design, implementation, and support in their specific order without backtracking. Now, let's examine each of the SDLC phases and the objectives. First, project planning. The objective of project planning is to identify the scope of the new system, ensure that the project is feasible, and develop a schedule, resource plan, and budget for the remainder of the project. In this phase, the main topics of concern is project management. Project management for an IT project is no different from project management for any other engineering projects. However, it would be advantageous for a project manager to be knowledgeable of the domain of the project which he is managing. Following project planning is analysis. In this phase, it is important to understand and document in detail the business needs and the processing requirements of the new system. This is a very important phase as all the following phases will depend on the correct understanding of the requirements of the system. Any misunderstanding will lead to wrong design, incorrect implementation, and ultimately will not achieve what the user wants. Following the analysis phase is the design phase. The system designer will then proceed to design the solution system based on the requirements defined and the decisions made during the analysis. Hence, you can see the output from the analysis phase becomes the input for the design phase. Once the design is complete, the system programmer will begin to build, test, and install a reliable information system with trained users ready to benefit as expected from the use of the system. Once the system has gone live, it is important to keep the system running productively initially and during the many years of the system's lifetime. This will be the focus of the support phase of the software development life cycle. As mentioned on the previous slide on software engineering activity categories, one of them is technical methods. One of these technical methods that we will be looking at is the Unified Process or UP methodology. This methodology is the most influential object-oriented system development methodology. This methodology is well suited to tackling large and complex systems. It is a methodology that adopts an iterative and incremental approach in software development. The activities in this methodology is centered on the divide and conquer principles. What this means is that the system developer plan out intermediate deliveries of system functionalities based on their priority. This methodology differs from the conventional waterfall methodology whereby the system developer delivers the complete system at the end of the life cycle. However, this methodology consists of an elaborate set of activities and deliverables for every step of the development process. Next, we are going to take a closer look at this UP methodology. The software development process based on this methodology has its own system development life cycle. The life cycle consists of four main phases. These phases are inception, elaboration, construction, and transition. As you can see, the phases are not analysis, design, implementation, and support as in the traditional software development life cycle. For each phase of the development, it can consist a number of iterations. And each iteration involves a complete cycle of numerous disciplines such as the requirement, design, implementation, and test discipline. Let's look at an example of a project adopting the UP lifecycle model. As mentioned in the previous slides, there are four phases: inception, elaboration, construction, and transition. And in each phase, there can be one or more iterations. In each iteration, there is a series of tasks that must be undertaken. This series of tasks are grouped into disciplines. There are altogether 9 disciplines in the Unified Process model. These 9 disciplines are shown here. Assuming that this project is not terribly complex, so the inception phase only needs one iteration. So, for this iteration, the tasks listed in the 9 disciplines must be undertaken. Once the iteration in the inception phase is complete, the project proceeds onto the next phase, which is the elaboration phase. For the elaboration phase, the project was divided into 2 iterations. Similarly, for each of these 2 iterations, all the tasks in the 9 disciplines were undertaken. After the elaboration phase, the project moves into the construction phase. The construction phase of this project was divided into 3 iterations. Once again, in each of these iterations, all the tasks in the 9 disciplines were undertaken. Finally, the project proceeds on to the transition phase. There is only one iteration in the transition phase of this project. As before, all the tasks in these 9 disciplines were undertaken in this iteration. What you see here is an illustration of what a project will look like if it adopts the UP lifecycle model. In this example, the project has 7 iterations, and each iteration is like a mini project which has to include the work in most of the disciplines and ending with a stable executable system. What differentiates this approach from the traditional waterfall lifecycle model is that it is possible to backtrack from one iteration in a particular phase of the lifecycle to an iteration in the previous phase. This allows any issues or concerns to be re-examined or analyzed in the previous phase so that any correction or rectification can be carried out before proceeding on. So, how many iterations should there be in each phase of a project? Well, this will depend on the type, size, and complexity of the project. Next, we will look into each of the UP phases and their objectives in more detail. The UP phases and their objectives. Inception. The objective of the inception phase of the UP process is to develop an approximate vision of the system, make the business case, define the scope, and produce a rough estimates for cost and schedule. This is similar to the analysis phase in the software lifecycle model. The elaboration phase. The objective of the elaboration phase is to refine the vision, identify and describe all the requirements, finalize the scope, design and implement the core architecture and functions, resolve high risk, and produce realistic estimates for cost and schedule. This phase straddles the analysis and the design phase of the software development lifecycle. The construction phase. The main aim of the construction phase of the UP process is to iteratively implement the remaining lower risk, predictable and easier elements and prepare for deployment. The construction phase is similar to the implementation phase in the software development lifecycle. And finally, the transition phase. The objective of the transition phase is to complete the beta test and deployment, so users have a working system and are ready to benefit as expected. The transition phase is similar to the support phase in the software development lifecycle. Iterations is a key feature in the unified process. So what does it mean exactly? We have already come to know that each phase in the unified process can have one or more iterations. And iterations is like a mini project that has a duration to complete part of the system. Hence, each iteration sort of has its own life cycle as well. There must be a clearly defined objective to be achieved at the end of each iteration. And all iterations involve activities to varying degrees from all 9 disciplines. Disciplines in unified process. A discipline in the unified process is defined as a set of functionally related activities. And activities are work to be carried out in each discipline that produces artifacts. Artifacts are UP work products. And the purpose of these work products are to document the various aspects of the system. Examples of work product can be a model element, a document, source code, or even executables. Now, let's examine in more detail the unified process disciplines. As we know, there are altogether 9 UP disciplines. These 9 UP disciplines are further categorized into 2 main groups. These 2 main groups are the UP development disciplines and the UP support disciplines. There are 6 main UP development disciplines. These 6 main UP development disciplines are business modeling, the requirements discipline, the design discipline, the implementation discipline, the testing discipline, and the deployment discipline. These disciplines are used for a specific duration of the UP development lifecycle. Now, let's look at the second group of UP disciplines, the support disciplines. The 3 support disciplines are the project management discipline, the configuration and change management discipline, and the environment discipline. The activities in these 3 disciplines are employed throughout the duration of the UP development life cycle. That is why they are called the support disciplines. Next, we will visit the disciplines in turn and see what are the activities included in each of them. The business modeling discipline. The objective of the business modeling discipline is to understand the business environment under which the intended final system will be operating in. The activities included in this discipline are understanding the surroundings, create the system vision, and create business models. The requirements discipline. The objective of the requirements discipline is to understand and document business requirements through discovery and understanding. The activities included in this discipline are gather detailed information, define functional and non-functional requirements, prioritize these requirements, develop user interface dialogues for these requirements, and finally, to evaluate these requirements with the users. The design discipline. The objective of this discipline is to design the system based on the requirements identified in the requirement discipline. The activities included in this discipline are design support services architecture and deployment environment, design the software architecture, design use case realizations, design the database, design the system and user interfaces, and design the system security and controls. The implementation discipline. The objective of the implementation discipline is to build or acquire needed system components. The activities included in this discipline are build software components, acquire software components, and integrate software components. The testing discipline. This is a critical discipline to evaluate the system under actual conditions. The activities in this discipline are define and conduct unit testing, define and conduct integration testing, define and conduct usability testing, define and conduct user acceptance testing. One thing to note is that acceptance testing occurs throughout the project as the system is being built. The last of the development discipline in the UP disciplines is the deployment discipline. The main objective of this discipline is to conduct activities to make the system operational. The activities included in this discipline are as follows: acquire hardware and system software, package and install components, train users, convert and initialize data. The activities in the deployment discipline are most prominent in the transition phase. The remaining disciplines are the supporting disciplines in the UP process. The first of these is the project management discipline. This is the most important support discipline to provide planning and management activities throughout a project. The list of activities included in this important discipline is as follows: finalize the system and project scope, develop the project and iteration schedule, identify project risks and confirm feasibility, monitor and control the project's plan, monitor and control communications, and finally, to monitor and control risks and outstanding issues. The second of the support disciplines is the configuration and change management discipline. The objective of this discipline is to produce plans and procedures for tracking changes and versions of components. The activities in this discipline are to develop change control procedures and to manage models and software components. These activities are largely applied to requirements, design, source code, and executables. And finally, the last of the supporting disciplines is the environment discipline. The main objective of this discipline is to manage the project team development environment, which includes available facilities, design of the workspace, and forums for team communication and interaction. To achieve this, the project management team must select and configure the development tools, tailor the UP development process, and to provide technical support services. We have now come to the end of this session. Let's summarize what we have covered. We had looked at the software development life cycle, which consists of a set of activities that are required to complete a system development project. We examined one system development methodology, the unified process, which adopts an iterative and incremental development life cycle. We learned that the unified process has 4 phases: the inception, elaboration, construction, and transition phase. We also learned that all unified process phases can consist of 1 or more iterations, and that each iteration involves work in 9 UP disciplines. And finally, we have looked at each of the 9 disciplines in turn and examined what activities each discipline entails. Thank you all very much for viewing this lecture. If you have any feedback or comments, do feel free to post them, and do subscribe to this channel for more lectures.